Okay, we are now going to review how to do the worksheet titled Multiple Covalent Bonds. But first before we get started on the drawing, let's review some of the types of covalent bonds. So first we have a single covalent bond, which is when two atoms share one pair of valence electrons. So when we draw a single covalent bond, we draw it as one line between atoms. A double covalent bond is when two atoms share two pairs of valence electrons. And when we draw a model of a compound, we draw a double covalent bond as two dashed lines on top of each other. Lastly, we have a triple covalent bond, which is when two atoms share three pairs of valence electrons. And this, when we draw it, looks like three dashed lines between two atoms. Okay, so let's move on to the first example, and we will draw H2CO. So as we know, if we have a compound with carbon, nitrogen, or sulfur, those are going to be our central atoms. So in this compound we have a carbon. So we'll go ahead and draw carbon as our central atom. So carbon is going to be bonded to an oxygen, and it's also going to be bonded to two hydrogens. Our subscript here tells us that there's two hydrogens in the compound. Okay, so we have our skeletal structure here, and now we'll fill in valence electrons of each atom. So if we take a look at our periodic table for valence electrons, we look at carbon. We see it's in group 4A, and so it has 4 valence electrons. We will go ahead and draw those. 1, 2, 3, 4. And hydrogen is in group 1A, so it has 1 valence electron. So 1 valence electron for this hydrogen, 1 valence electron for this hydrogen. Lastly, oxygen is in group 6A of the periodic table and has 6 valence electrons. 1, 2, 4, 5, 6. Okay, so hydrogen has 1 valence electron, and it is missing 1 valence electron from having a complete first orbital with 2. So each of these hydrogens are wanting to gain 1 electron. Carbon has 4 valence electrons and needs an outer shell of 8, so it's searching to get 4 electrons, and oxygen is searching for 2 more valence electrons to get its 6 valence electrons up to 8 for a complete octet. So let's start drawing our covalent bonds. So we know hydrogen has 1 and is looking for 1. So it can go ahead and form a covalent bond with the carbon. So hydrogen has now 2 and carbon now has 5 valence electrons. This hydrogen can do the same thing and form a covalent bond right there. That hydrogen now has 2, has a complete forced orbital. Now carbon has 6, it's looking for 2 more. Oxygen also has 6 and is looking for 2 more. So we're actually going to have a double covalent bond here between carbon and oxygen. We have the sharing of 1 pair of electrons here and the sharing of a second pair of electrons here. So now carbon has 8 electrons through its 4 covalent bonds. Oxygen now has 8. 1, 2, 3, 4, 5, 6, 7, 8. Each hydrogen has 2. So now we have all of our octet rules satisfied. So we're going to translate our model here into our final answer. And remember that anytime we drew a circle representing a covalent bond, we'll change that into a dash in our final answer. So we have a carbon covalently bonded to 2 hydrogens, and also doubly covalent bonded. Right here we have 2 pairs of electrons being shared between carbon and oxygen. Okay, so now we need to draw our valence electrons. So hydrogen has a total of 2. Those are represented here in the bond with 2. And same thing with this hydrogen. Oxygen here has 1 pair of valence electrons, 2 pairs, but we see it has 1, 2, 3, 4 other valence electrons. So we fill those in, and carbon, all of its valence electrons are represented in the bonds there. So that would be your Lewis dot structure for H2CO. Okay, moving on to our second example, we have HCN. So, like we know, when we have a carbon atom, it is typically going to be our central atom. So we'll go ahead and draw carbon here, and we'll draw a nitrogen and a hydrogen atom on either side of the carbon. Next step is to figure out how many valence electrons are on each atom. So let's start with carbon. Carbon, again, is in group 4A, so it has 4 valence electrons. 1, 2, 3, 4. Hydrogen is in group 1A, has 1 valence electron. Nitrogen is in group 5A, so it has 5 valence electrons. 1, 2, 3, 4, 5. Okay, so hydrogen has 1 valence electron and is looking for 1 more valence electron. That way its first orbital is full with 2. Carbon has 4 valence electrons and is looking for 4 valence electrons. That way its second orbital has a complete octet of 8. Same thing for nitrogen. It's looking to get 8. It has 5, so it needs 3 more valence electrons. So what typically hydrogen does is form a single covalent bond, like we've seen. So we're going to have a bond here between hydrogen and carbon. Hydrogen is now happy. It has 2 valence electrons for its valence shell, which is the first orbital. Carbon now has 5, and it's looking for 3 more. Same thing as nitrogen. Nitrogen has 5 and is looking for 3 more. So we can make 3 covalent bonds between carbon and nitrogen. Right here we have the sharing of 1 pair of electrons. Here we have the sharing of 2 pair of valence electrons, and if we draw this one like that, we have the sharing of 3 valence electron pairs between carbon and nitrogen. So if we translate that into our Lewis dot structure, we have HCN. There's 1 covalent bond between hydrogen and carbon, and there's 1, 2, 3 electron pairs being shared between carbon and nitrogen. Now we go back and we draw any extra valence electrons that aren't represented in bonds. And we see right here we have 2 valence electrons on nitrogen that are not in the bond. So there you have your structure for HCN.